myself, Sundari Mastri from CC third year. So, as a part of my machine learning and techniques laboratory, we're going to look into the third experiment, which is regression analysis. Whereas in machine learning algorithms, the learning is divided into two different types. One is supervised learning and unsupervised learning, whereas regression is a part of supervised learning. So the main aim of this experiment is to implement a linear regression and multiple linear regression and also logistic regression using Python machine learning scikit-learn libraries for the model creation and evaluate their performance based on statistical metrics and visualization. So as we are going to look into it, first we are going to import the necessary libraries which are pandas, matplotlib for visualization and numpy for measuring statistical metrics. So here we are going to implement this without any scikit-learn libraries and any built-in functions. First we are going to import the dataset, which is CSV file, and then we are going to perform data cleaning to find the missing values and then impute the same with the mean. So as part of it, here we are going to check for the missing values in the data set. If any missing values are found, we are going to replace it with the mean value from the respective column to maintain the data consistency. So using df.mean function, we are going to increase all the missing values with the definite column mean. Next, we are going to select the independent and dependent variables. So in linear regression, there are two classifications, which are simple linear regression and multiple linear regression. Whereas in simple linear regression, we are going to take only one independent variables. Whereas in multiple linear regression, we are going to take some different amount of independent variables which influences the target variable. So it is in simple linear regression, we are going to take one independent variable which is sepal length for the given iris dataset and one dependent variable which is target variable which is also known as y. We are going to take sepal width. So after calculating the length, we are going to compute the b0 and b1. For regression model analysis, we are going to use a formula which is known as a1 is equals to a0 into x plus y. So whereas y is known as dependent variable and x is known as independent variable. So for that, first we are going to calculate b1 and b0, whereas also nothing but a0 and a1. So the basic formula behind is y predict is equals to b0 plus b1 into x, whereas c is b0 is known as constant and x is intercept. So here we are going to first calculate the x mean and y mean in order to calculate the b1. The formula of b1 is np dot sum of, which is also known as x minus x bar into y minus y bar by root over x minus x bar whole square. So derive the formula, we are going to use the same thing and going to derive the b1. After deriving b1, we are going to check with the b0 function, and to derive b0, we are going to use the formula y predict is equals to b0 plus b1 into x. And then after here, we would get the values of b0 and b1. Next, we are going to formulate the equation for y predict. Y predict is equals to b0 plus b1 into x bar. So here we get the y predict of the overall rows and columns in the dataset. So once after this, we are going to calculate the SSE, which is known as sum of squared errors. In this step, we measure the total square difference between the actual and predicted values using np.sum, which is known as sum function. So here after we are going to calculate the root mean square error using standard deviation of predicted errors. And then we are going to calculate the coefficient of determination of R2 square. R2 square is computed from RMSE. Here we are going to calculate the coefficient, which shows how well the regression model explains the variance in the dataset. Next, we are going to plot the regression line along the dataset. Where data is not well aligned on the regression line, it is not yet accurate. Finally, using the recursion equation to predict the value of y for a given input of x, we are going to take the function and going to in place all the values in it. So for definite x value, we could get the y prediction, which is predicted y would be 3.076. So this is how all the simple linear regression works. Coming to multiple linear regression, after performing data cleaning, we are going to take independent, definite amount of independent variables. As we can see here, we have taken two independent variables which are sepal length and petal length in order to determine the sepal width in centimeters. So once after deriving it, we are going to perform and compute the regression coefficient and intercept using the mathematical formula for simple linear regression. So as you can see here, y predict is equals to b naught plus b1 into x1 plus b2 into x2. So once after we get the y predict, we are going to find and calculate the sum of squared error. So by sum of squared error, we could actually see the difference between actual and predicted values from the dataset. Next, we are going to compute the root mean square error in order to measure the model prediction accuracy. Hereafter, we are going to calculate the R square value in order to evaluate how well the independent variables explain about the target variables using R square metric. And we are going to predict y using the definite x values. If the sepal length is 5.8 cm for x1 and 4.2 cm for x2, then y predict would be 2.89 according to multiple linear regression. Okay. Next, looking into logistic regression. Logistic regression is a part of classification and regression. So looking into this logistic regression, first we are going to import the dataset and perform the data pre-processing for handling missing values and null values in the dataset. And next we are going to choose the independent and dependent variables from the given dataset, where independent variables would be sepal width, sepal length, petal width, and petal length, whereas target variables and dependent variable would be species. So we are going to determine and predict the species from the given independent variable features. And then we are going to find the cost of error, and in order to reduce the cost of error using gradient descent. So here we are going to implement the gradient descent to minimize the cost function and update the model parameters accordingly. So in order to calculate the cost and error and to reduce the cost and error using gradient descent in logistic regression, instead of predicting the continuous values like linear regression, the model predicts the probabilities between 0 and 1 using the sigmoid function, whereas the sigmoid function converts the linear value into a probability between 0 and 1. If the probability is greater than 0 0.5, the model predicts the class 1. Otherwise, it predicts the class 0, which means it collapses to either 1 or either 0. So, as a part of it, using sigmoid function, we are going to take the three parameters which are x, y, and theta, and going to calculate the cost function and returning the cost. And using gradient descent, we are going to iterate through it and check for the probability. So once after we find the probability, we would get the final theta value, which is the cost function. So to measure how well the model is performing, we use this cost function. The cost function calculates the difference between the predicted probabilities and the actual labels given from the data. The cost function is also known as log class or cross entropy class. The goal of this training is to minimize this cost function so that the model prediction become closer to the actual variables from the given dataset. And the gradient descent method, as we have seen here, is work to reduce the error. It mainly focuses on minimizing the cost function. So gradient descent updates the weights iteratively by using the iteration for loop we have used here, and then it predicts the error and then update the weights accordingly into the dataset. So once after we derive this theta values and updating the cost function and errors, the graph of cost versus iterations would be like this from the logistic regression. And at the very last, we are going to find how well the model worked and how accurately it gives us the predictions. So using the same sigmoid function, we are going to check for the model accuracy. After training the model, we test it on unseen data and calculate the accuracy of the model, which we can call it also as generalization. Accuracy represents the percentage of correct predictions by the logistic model. So as we are concluding with this, simple linear regression and multiple linear regression or logistic regressions are a regression models which would help in predicting the outcome from performing on an unseen data. Thank you.